All right, well, we're back to this thing. I kind of put it aside because I was trying to do something with the vacuum tubes that was proving to be super challenging. And in spite of working on it quite a bit, I found that the vacuum tubes just weren't really playing nice with the digital electronics. And so I had to scrap that idea, but I still wanted the vacuum tubes to be in the circuit. That's a key aesthetic part of the circuit. And so I was thinking a little bit about, well, what else can the vacuum tubes do besides controlling the sleep mode? So what they were going to do is control the sleep mode. They would have been this flip-flop circuit here would have been controlled by the vacuum tubes as a flip-flop circuit on the vacuum tubes. But instead, what I decided to do is to use the Hartley oscillator to control some diodes to create the negative voltage reference for the vacuum fluorescent displays here. So how the circuit was currently working is we had a 15-volt voltage regulator down here, and that fed this 555 timer down here, which was acting as an oscillator, and then the oscillator connected to two capacitors in a certain orientation provides a negative voltage reference. And so I still have that negative voltage reference in the circuit, which is kind of cool because, you know, if the vacuum tubes ever die, which they probably will, it'd kind of suck if the circuit stopped working just on account of the tubes dying. Not sure, you could just buy more tubes. But you know, these are these are probably, you know, 30 to 50 years old. So who's to say what the lifespan is on them? So what I decided to do is to keep the negative voltage reference from the digital circuit, and I also generate a negative voltage reference from the vacuum tubes. And what I'll do is I'll put them on a single pole double throw switch, and that way, you know, it can be cool and still operate off the vacuum tubes. But if they were to ever to die, you could just flip the switch and operate it off of the digital negative voltage reference, and that would allow the vacuum fluorescent displays to continue to work. So, yeah, it was a bit of a battle to get this thing back together in working state. I'm glad that I had a schematic for it. And, you know, so it's essentially done. The only distinction is that currently 4 vacuum tubes would have created a 24-volt requirement. The heaters in the vacuum tubes, they actually have heaters. You can see them glowing. The heaters in each one are a 6-volt heater, 300 milliamps each. And so by having 4 vacuum tubes, you know, a 6-volt drop across 4 of them is 24 volts. I could have powered them just straight from the 24-volt supply, and, you know, everything's good. But it gets a little bit tricky when I have only 3 vacuum tubes, because, you know, now I need 18-volt supply, and I don't really have an 18-volt supply. Now, what I can do is use a voltage drop resistor and drop my voltage from 24 to 18 volts. And I know it's going to draw 300 milliamps. And that tells me I need to buy a 20 ohm resistor at about 2 watt minimum power resistance or power wattage. So I don't have anything like that. I have a couple power resistors, but nothing in that that specification. So I'll have to order a power resistor, and that will drop my 24 volt source to 18 volts. And 18 to 12, 12 to 6, 6 to 0. And so I'll be able to power all 3 of those off of the 24-volt supply, just, you know, wasting a little power to heat through a resistor. But yeah, so these are actually generating a negative voltage, and I have the negative voltage on the oscilloscope here. So we're on a 2-volt scale. So right now it's generating just a little bit shy of negative 4 volts. And that is being powered by an 18-volt supply here, and again, it's drawing about 300 milliamps, so that's exactly what we'd expect. So the small change in the future is that, you know, eliminate this supply, which is just powering the heaters of the voltage of the vacuum tubes, and then put that all into a single 24-volt supply, you know, with the resistor. But yeah, so using just an external supply, I can power up these tubes, and then the other external supply is powering everything else. And so, you know, we're in sleep mode right now. So we can bring something on the screen here. Well, it looks like we don't have any digit into the multiplier, so let's put it into programming mode. All right, so the third LED tells us that we're in programming mode. The flashing LEDs tell us we're in programming mode. So I don't know, let's put like a 3 in there maybe. Okay, now 3 times 1 is going to be 3. That's a 3. So it's working just fine. We'll do like 3 times 9. There we go. And we can see that the negative voltage supply is holding on just fine. As long as it's negative, it works fine. So the vacuum tubes need a negative voltage reference in order to shut off completely. Even if they just hook to ground to 0 volts, they'll still glow a little bit. So they need just some negative voltage reference in order to turn off completely. So we're hanging around here at under no load, just about 4 volts. And then when we put a load on the system, nope, I didn't catch. Oh, I still think there's a little bit of capacitance in the wires that's causing this dial to not register sometimes, but there we go. So get it, and then you'll see that it drops down here as the circuit's counting to about 2.5, 3 volts. But again, as long as it's negative voltage, that's fine. The distinction of the digital circuit here is this one, I mean, technically it's unregulated because it's just being generated off of an oscillator and some capacitors. But that oscillator and capacitor supply is regulated through the 15-volt voltage regulator here at an amp. So at a full amp, this thing just stays at a negative 12 volt pretty much always. So yeah, if there's ever any issue with generating negative voltage from the vacuum tubes, then we can just switch it over and use the negative voltage supply on the digital side. But this is pretty much it. I just need to buy the resistor to be able to run these off of the main power supply, and then a single pole double throw switch in order to flip the voltage reference between digital or analog. And I would say this circuit is done, and it's time to start converting it to a circuit board and doing all the machining on the case and all of the next steps. So that's pretty cool. It's working.